Hey there, welcome to ABC24 Sci Talk. This is a new podcast-style show on 24 Plus, talking about science, talking about weather a lot, and with me is Jeremiah Hall. Jeremiah,
thanks for
yourself.
me. Thanks for joining us. We're glad that you guys are here. I'm Jeremiah Hall. I'm a journalist and a digital content producer with ABC24. Kit and I spend a lot of time close to each other in the office here because of how our desks are set up, and as a journalist, I'm someone that is naturally curious, and when you put someone that's naturally curious next to a big brain, we just have a lot of conversations. We've had a lot of conversations about the science of everyday life, and that's kind of what we hope to get into here on ABC24 Sci Chat.
Yeah, and hopefully this is a way to improve science literacy, just bring you into some of the scientific terms that you may hear in day-to-day, or sometimes I'll bring them up in my show when I'm talking about the weather. And a lot of people are just like, what in the world is a dew point? What are these other terms that you don't really deal with in the day-to-day life that maybe was covered in high school and you need a refresher, or you never took that class, so you're just interested in learning more about it. So that's what we hope to get into on this show.
Yeah, Kit says a lot of people. I'm a lot of people, and that's what we hope to get into. Like Kit just said, we hope that you can take something from this. I know that I have. So yeah, let's get into it.
All right, so this week for our premiere show, we're talking about precipitation types. Earlier, we had some rain, snow, mix precip across the Mid-South, and we've got another chance on Thursday as well. And we're headed into the winter season. So this is a very relevant topic that we all kind of need to be refreshed on.
Yes.
Yeah. All right, so first off, everyone knows rain. Rain is pretty straightforward. Whenever we have rain, usually it starts in a cloud, and the water cycle, you get evaporation, condensation, precipitation. Those three are sort of the main three of the water cycle.
Okay.
And there's a few other things that can happen while that precipitation is happening. Of course, condensation is just liquid water that comes from the air as water vapor. Water vapor is different from steam. It's actually small, little, teeny little microscopic droplets, versus steam is something that has been heated past the boiling point. So you don't have to be boiling for evaporation to occur. So that's one thing to think of is it's water in a gaseous form, or in a vapor form, not a gaseous form.
So when someone says it's steaming outside, it's not.
Right. Whenever you see that steam rising off of the pavement after a summer thunderstorm, that's evaporation occurring, not boiling. But when you boil a pot, that's actual water molecules that are becoming free from the water.
Already learning things.
Yeah, so it's a very subtle difference when you get to vapor. So when we are talking about precipitation, we need water vapor present.
Okay.
And there's something called a condensation nuclei. It's a very specific term. I'm already getting into the weeds here. But basically, water can't just bind together and get millions and millions and millions of water molecules together. It has to have something to attach to. Luckily, we have pollen. There's dust, even sea salts, soot from a fire. All of these things are tiny little particulate matter that water can actually attach to. And it all attracts to that little particulate, and then it begins to create a water droplet. So we start with that. That's what we're going to start with for all precipitation types, is some small imperfection in the atmosphere, some small particle. Again, could be dust, could be dirt, pollen, what have you. And then that's where we start to see some amount of precipitation begin. So that's the life, the beginning of the life of a raindrop.
Wow. So rain does not just appear.
Right.
So it doesn't just appear. It needs something else to kind of grab onto.
Right.
Didn't know that.
So that seed is where we start to see a raindrop growing. Maybe it bumps into another small seed with a little bit of water on it, and they start to sort of accumulate and aggregate together. Okay. And then you get a raindrop, and it actually forms a spherical shape. We usually have like that teardrop shape of a raindrop. It remains spherical for most of its lifespan.
Really?
Some of the larger water droplets, raindrops, once they get like a few millimeters across, like 4 or 5 millimeters across, they actually start to squish a little bit. Because once they're heavy enough, they start to fall. And just the upward pressure of air as it's falling through the air actually sort of squishes it and makes it more oblate rather than just a perfect sphere.
Sure.
But raindrops are round, not teardrop.
Huh. They've been lying to us.
They have. It's simpler to look at it and just make a little raindrop shape or teardrop shape. But water, just because it's sticky, it sticks to itself.
Sure.
That's the surface tension of water. It will always, it'll preferentially shape itself into a sphere as much as it can. So rain goes all the way down. Rain's very straightforward.
Sure.
Sometimes rain can form with a snowflake that then melts into a raindrop.
Okay.
So sometimes really, really high up in the clouds, you'll just have a frozen layer, and you'll have snowflakes beginning to form, and then it warms up as it goes down. Early spring showers typically form like this when it's just that light mist. The thing is, the big fat raindrops in the summertime, those don't usually start as snow, because whenever you have a snowflake, there's not a lot of water in it, so it tends to melt into a really small raindrop. That's how we get some of those, like I said, spring, fall, wintry, drizzly mess.
Sure.
Those are really small raindrops. So snow is very different.
Okay.
Whenever we start with that imperfection, as soon as a water molecule attaches, it does so in a crystalline lattice. Because it's frozen, it doesn't attach as a liquid. Because it's below freezing, it attaches as a solid form of water.
Really?
Mm-hmm.
So it still needs that particulate, that dust, and then a frozen piece of snow, can I say that?
Yeah.
Just sort of attaches to particulate.
Yeah, and there's a couple of different methods of snow growth. The basic types of snow are needles, plates, columns, and dendrites.
Oh, of course.
Those are the four major
dendrites
breeds of of snowflakes.
Okay.
So your classic six-sided snowflake. If you ever see an 8-sided snowflake, it's wrong.
It's wrong.
It's wrong.
Wrong.
You get those long axes, those three little needles that sort of cross one another.
Sure.
Imagine you start with those needles. Now you start to grow another needle halfway up each needle.
Okay.
And each time you add a needle, you sort of get this fractal pattern where it looks the same the farther down and down and down you go.
Yeah, sure.
And so that is your classic snowflake. That's what we call a dendrite. It's your classic snowflake, and that's going to be the most productive snow you'll ever see. That it's going to grow quickly. It's going to grow abundantly, and you'll just have this heavy, heavy snow coming down from that.
I had no idea. So when we're in elementary school and we're cutting up pieces of paper to create snowflakes,
right?
Are we creating dendrites?
Yes. So
wow.
Those are dendrite snowflakes. Those are your classic snowflake.
That's cool.
But columns are similar to needles, except they are a column. They have width to them. It'd probably be better if I started with a plate. A plate is just a hexagon. It's just a hexagon, flat. That's it.
Really?
Mm-hmm. And you can get these plates of ice crystals a lot of times in cirrus clouds, really, really high up.
Okay.
If you've ever noticed at like dawn or dusk, and you've got that thin layer of clouds that are filtering the light, and then sort of to the left and right, you'll see kind of a rainbow color. It's called a sundog.
Okay.
It's another atmospheric optics thing similar to a rainbow, but it just refracts the light. That comes through flat hexagons that are ice crystals that refract the light through, and it creates sort of to the left or right of the sun a little prismatic effect.
That's what a sundog is.
That's what a sundog is.
I know the word, but I didn't know. Okay.
Yeah, so it's similar to a rainbow of just light getting bent through something.
How cool.
And in this case, ice. But if you take that hexagon and you make it into a prism, we call that a column. That's another way you can create a snowflake.
Sure.
And all of these different 4 types of snowflakes, they're very dependent on the conditions of the air where they are.
Okay.
One of the things we always say is no two snowflakes are alike, right?
Mm-hmm.
That's
Heard that.
because the snowflake shape itself is highly dependent on its path.
Okay.
The thing is, a snowflake is going to go through, and as it's falling through and floating down through, it's going to move into an area with higher humidity. So it's going to
Sure.
gobble up that moisture. And then it moves into an area with no humidity, so or low humidity, so it doesn't have anything to grow onto.
Okay.
And then the temperature changes, and then the dew point changes, and all of these things are always changing a little bit as it falls down. And so that's why each snowflake looks different, because they are all taking tiny, minuscule paths that are slightly different from each other.
That's really, really cool. I didn't know that.
Yeah.
I guess that's why we're here.
Yeah. And, of course, we're going to take a quick break, but we've still got a lot of different types of precipitation to talk about, so we'll be right back after this. Welcome back to ABC24 Sci Talk. I'm Kit. This is Jeremiah. We're talking about different precip types today.
And we learned about snow in the first segment. Kit taught me about dendrites, which are the general snowflakes that we see when we're little kids and things like that. And as we were talking about precipitation, our producer, Michael Antonio, had a cool question.
So my question is, we talked about snow and that kind of precipitation and rain, but what's the difference between sleet and freezing rain?
Yeah, so sleet and freezing rain are kind of the other two winter precip types that we are most familiar with. Sleet is basically, remember how we were saying sometimes rain can form as a snowflake? I already talked how snowflakes form. And then when it gets into a warm layer, because the atmosphere isn't always consistent. It's usually very warm at the surface, and then it gets colder and colder and colder the higher up you go.
Sure.
That's typical. But sometimes you can get a little warm layer that might be above freezing, about a mile up above the surface, or some distance above the surface. Because when you have a cold front coming through, that's actually going to be more dense. It's going to be heavier. So it's going to sink down to the surface, and as that pushes in, it's going to lift the warm air above it. So sometimes that warm air can transport really far north across the lower warm layer or cold layer. So these different layers, eventually that warm layer is going to get to freezing just because it naturally cools down. But if you have snow forming up in the cold, and then it falls into the warm above freezing, that completely melts it.
Sure.
Snow melts when it's warm.
Sure.
The sad truth
Turns
every
out.
child learns.
Turns out.
But if it falls down into that freezing layer, if it's thick enough, it can actually completely refreeze into a small little pellet of ice.
Okay.
And that's different from hail. We'll talk about hail in a little bit, but sleet will fall as just these tiny little pellets. You'll hear it. It sounds kind of like a rain stick. It's just
Sure.
a little bitty tick, 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 tick sounds of...
Just like that.
Yeah,
Sounds
just like
just like sleet.
So sleet is hard ice pellets. Like it is frozen completely.
Okay.
Freezing rain is different.
Okay.
Freezing rain is much worse.
Uh-oh.
So freezing rain, it has the same process where it's cold, it warms up and melts, and then it doesn't have enough time, or it doesn't have enough cold air for it to completely refreeze to sleet.
Okay.
Freezing rain is kind of incomplete sleet.
Oh, okay.
Not intending to rhyme here.
Not that time.
So freezing rain is rain that freezes. End of show. So when it falls into that cold layer, it does begin to cool down, and for some reason it's not cold enough, or it's not deep enough of a cold layer to get it to freeze entirely to sleet. So when it falls on the ground, as water does, it'll spread out, and then it freezes.
Really? Okay.
And sometimes the irregularity of the ground or the imperfections of the ground can actually take a liquid water droplet that's technically below freezing. We call it super cooled.
It's my high school nickname.
Doubtful. It can be super cooled below the freezing mark, and as soon as it hits the surface, it locks into ice.
Okay.
And so you get this thin layer of ice from one little water droplet, and then another layer, and another layer, and another layer. And that buildup of tiny little layers of ice is what creates that glaze of ice on everything that, it's very, very slick. This is the most dangerous precip to drive in.
Sure.
Because ice has very low friction, and that's why freezing rain can be so detrimental. It's also the fact that it sort of adheres to anything it comes into contact
Sure.
with. So instead of rain just dripping off a power line, or snow it's too heavy, so it's kind of just it breaks apart. It doesn't hold together very well.
Sure.
Ice holds on to itself very easily, and ice likes to spread. So if you have something that's super cooled falling onto ice, it's going to freeze. It'll sort of seed the ice crystals of that next raindrop. And so the power lines start getting heavier and heavier and heavier. Tree limbs get heavier and heavier. And so that's why freezing rain leads to so many power outages, because of just all of the weight of the ice that accumulates. Every quarter inch, it adds pounds and pounds and pounds of weight to a single limb. And so that can cause widespread power outages.
So the way that I understand it, sleet leaves the clouds. It leaves the clouds frozen.
Mm-hmm.
It unfreezes on the way down, but by the time it reaches the ground, it freezes again.
Right.
So it's little balls of ice hitting the ground.
Yeah, just tiny, tiny little pellets.
Freezing rain, on the other hand, leaves the clouds frozen.
Mm-hmm.
Then it kind of melts on the way down, and then it almost gets back to freezing. And then once it meets those necessary conditions in our atmosphere, on our ground rather, when it meets those conditions down here, it freezes again.
Right.
So it hits the ground, spreads out, freezes. Whereas the sleet kind of hits the ground and just rolls into the curb.
Yeah, it's just gonna bounce and roll, and it'll still stack up.
Sure.
But the difference between sleet and snow is very big. It can take a lot of space, and
Sure.
all those little arms of it will lock together, and they add a lot of air in between. But sleet,
Oh,
since they're
okay.
small little pellets, they're going to pack together really closely.
Sure.
So that actually reduces the amount of accumulation. Where you could have 6 inches of snow, in sleet, it's only going to be an inch. So it's going to really
Okay.
change how much you see.
Sure.
But if all that sleet were melted into water and then frozen, it's going to be a quarter inch maybe
Okay.
of freezing rain. So sleet and freezing rain can really take a toll at like what we're expecting to see for snowfall totals.
Sure.
If it does just slightly turn into sleet or slightly turn into freezing rain, that's going to reduce the amount of volume that it can stack up in.
Okay. So whereas we generally measure, at least on the surface, we generally measure snow in inches.
Mm-hmm.
We don't always measure sleet in inches, right?
Well, we can.
Okay.
And it can be a lot of sleets to get up to an inch,
Sure.
but it would be a very heavy amount of rain at
Okay.
that point that would be converting to sleet when it hits the ground. But of course, freezing rain is, like I said, it's the most damaging, causes the most issues
Sure.
for power lines, and it only takes just a little bit of that ice to cause trouble on the roads.
Mhm.
You really should never drive during freezing rain. Snow, it can blow. It can be a little bit easier to get traction in, but freezing rain is the really tough one.
That's really cool. Well, I also wanted to ask you about some other types of precipitation, specifically hail,
Mhm.
maybe a little bit of fog,
Mhm.
but maybe we can get to that when we get back.
Yeah.
We'll be right back. Welcome back to ABC24 Sci Talk. I'm Jeremiah Hall, here with Kit Thomas. We're learning about precipitation,
Mhm.
winter precipitation. Earlier in the show, Kit explained how snow, sleet, and freezing rain were formed. All of those start in the clouds and then fall.
Mhm.
The way that I understand hail, which is a shallow understanding, but the way that I understand hail is much like snow, much like rain. It requires water vapor or water in some form to attach to particulate in the atmosphere, in our upper atmosphere rather. Rather than falling out of the clouds, hail sort of gets tossed up and it goes into colder parts of the clouds and maybe gathers more water and gets thicker and thicker as it falls and then rises. Am I anywhere near the truth?
Yes, very much. That's a great understanding of hail. Like you said, starts as rain, it falls, gets caught into an updraft. So whenever we talk about a thunderstorm, you'll often hear us use the word convection. You might be familiar with a convection oven. Convection is just the movement of air currents that can move air. You want that in an oven because then it keeps the heat source and the side away from the heat source, it keeps the temperature pretty even. So convection can lift the warm air and bring down the cold air, and it creates this whole cycle. So in there, you can get a raindrop caught. Like I said, it'll get pulled up.
Okay.
It gets frozen eventually, and then it falls back down because it's just not blowing as hard up there, and then it gets caught up again. And so as that happens, just like you said, you start to get layers and layers of ice. If you ever get a big piece of hailstone, you can cut it in half, and you can actually see the little circles of the layers of hail.
That's cool.
Yeah. So that's a really cool form, but that doesn't happen very much in winter.
Okay.
Because we don't have quite as much of a difference of temperature between the surface and the upper levels of the atmosphere. That'll happen a lot in thunderstorms during the summer, during the spring, because we do have a good amount of heat at the surface that can start those convection currents.
Okay.
Mm-hmm.
Okay. So I know, and I don't want to stray too far from winter precipitation. I know that hail is often present in tornado systems.
Mm-hmm. Right.
Is there any particular reason why they're more favorable to those conditions than any others?
Yeah, so whenever we have a tornadic thunderstorm, often a supercell thunderstorm, it's one type of storm. We'll talk about that in another episode. Oftentimes, you'll have a very powerful updraft.
Okay.
And sometimes that updraft is pulling in air at different angles at the surface, and that can induce a bit of rotation. So your updraft begins to rotate. And as you've got that updraft, you're making the hail already, but that rotating updraft can sometimes consolidate into a tornado.
Okay.
So if we're forming hail, that can start a tornado. Or the updraft that is forming the hail can sometimes start a tornado.
Okay. That's really cool.
A little bit of convection can happen during wintertime. And another precip type can form called graupel.
Graupel?
Graupel it's like that really puffy snowflake that's really crunchy.
Graupel?
Graupel. Graupel. It's legitimately called graupel.
This was not in the pre-show notes. Graupel?
Graupel.
Okay.
So basically, if you've got the convection going on, you've got a little bit of those heat currents going in. So you have up above the snow that's falling in, and then you'll encounter a little bit of liquid water droplets.
Okay.
And that will then attach itself to the points of the dendrite or the needle or the column, and then it starts to grow these little puffy little itty bitty spheres of ice on top of the snow. Because once the snow hits the ice, it actually freezes the ice bubble or the water bubble.
Of course.
And so it creates these little puffy snowflakes. It still counts technically as snow. It's just sort of a fifth type of snow.
So is a graupel dendrite a thing?
A graupel beginning from a dendrite, yes.
All right.
We'll be right back.
Graupel.
We're back here on ABC24 Sci Talk. Of course, we've been talking about the precip types we can see in winter as we're heading into winter, just starting off December now. We just saw some of these different precipitation types across the Mid-South, and we may still see them as we go through winter. So hopefully this has given you a more in-depth understanding of how rain forms, how snow forms, and what to look out for of the different precipitation types we'll be talking about on air.
And graupel.
And graupel.
And graupel.
Graupel's a good one.
So now that we know a little bit more about what we're looking at, what you guys are talking about when we tune into our meteorologist so we can make sure that we're staying safe, what can we expect for the rest of the season moving forward? I know that you can't forecast the entire season.
Right.
But How we looking, I guess?
So we've started off on a cold note. We may still have a swing back to some warmer temperatures at some point. It's going to be those temperature swings. But this past January and February, we had 2 big snowstorms that were unusual. We don't usually see a big snowstorm every year, but when we do, we celebrate.
Yeah.
It may still happen again. We'll have to wait and see. But, of course, ice storms are also frequent in the Mid-South.
Mm-hmm.
So that's the freezing rain we were talking about. It's the freezing rain, the sleet.
Sure.
Those are still possible.
Okay.
Can't tell you when or if it will happen, but still something to keep in mind.
So it's definitely happening, and school is canceled indefinitely.
Indefinitely.
Indefinitely. Well, thank you so much. I know that I learned what a dendrite is. I
Yeah.
know that I learned the word grapple. I know I learned the word grapple. We hope that you learned something too. We hope that you will join us again next week on ABC24 Sci Chat.
Sci Talk.
Sci Talk, excuse me, on ABC24 Sci Talk.
We went through a few different names.
Maybe we'll get it by next week. I'm Jeremiah Hall.
I'm
Here
Kit
with
Thomas.
Thank you so much.